Okay, so if we look at your information from your lab, let's start with the baking soda. Baking soda is known as sodium hydrogen carbonate, and that is NaHCO3, and then we heated it. So that's going to be our catalyst. So we're going to put heat over the arrow. All right, so we get three products out of this. One of them is sodium carbonate, which is Na2CO3, because if we go back to basics, sodium's a positive 1, carbonate is a 2 negative, so it takes 2 of the sodiums to match up to the carbonate. Okay, and that's just basic chemical formula writing. So I'm going to just get rid of that so I got some room here. All right, so that's one of the products. One of the other products we get out of this is CO2, and then the last product that comes out of this is H2O. Okay, so let's balance the equation first. I have 1 Na, 2 Nas, so I'm going to come over here and put a 2. That gives me 2 hydrogen, 2 hydrogen. I've got 2 carbon, 1 plus 1 is 2, 6 oxygen, 3 plus 2 is 5, plus 1 is 6. This is balanced. So all it required was the 2 coefficient at the beginning of the baking soda, and everything else balances out. This is a decomposition reaction. All right, so it decomposed. We started with 1 reactant, and we broke down into 3 separate products. So it's a decomposition reaction. All right, now let's talk about this reaction that we saw in the lab. When we placed a lit splint in front of it, it made the flame go out. All right, that is due to the carbon dioxide gas. Okay, so carbon dioxide gas is the one that will extinguish the flame. So in the lab tomorrow, if I do an experiment that the flame goes out, if the flame goes out, you know carbon dioxide is one of the products. Okay, so let's say I take carbonic acid. You guys would know it as hydrogen carbonate. All right, and I do something, I speed up the reaction, and I put a flame over it and the flame goes out. You know one of the products then has to be carbon dioxide. Let's look and see what else this could break down into. If I pulled the carbon and oxygen out of this, I could also break down the hydrogen and oxygen and get water. Okay, so when you predict the products, you want to look at what did the experiment show you. And so if the fire goes out, you knew carbon dioxide was one of the products, then you'd see what else is possibly left over, and in this case, water would be left over. We'd go to balance it, 2 hydrogen, 2 hydrogen, 1 carbon, 1 carbon, 3 oxygen, 3 oxygen. It happens to balance itself out. Do not be fooled and think that all decomposition reactions produce carbon dioxide. Not the case. We know hydrocarbon combustion produces carbon dioxide. There's a lot of things that can do it. All right, so I just happen to use 2 examples that were decomp, but make sure that you're aware that if carbon dioxide is produced, the fire will go out. So that's the product. Who cares what I started with? As long as the product shows that, then we know that's the one that's going to put the fire out. All right, let's look at another experiment we did with dihydrogen dioxide, otherwise known as hydrogen peroxide. We added manganese dioxide as a catalyst. We talked about that in class multiple times. This was not a reactant. It was just used to speed up this reaction, to speed up this decomposition. 2 things we get out of this are water and oxygen, okay? Not hydrogen and oxygen. Reason being is this actually isn't just oxygen. This is peroxide, which if you look at your periodic table, peroxide's this, O2, -2. So we're not splitting it into hydrogen and oxygen. We actually were splitting it into water and then the oxygen out of that, okay? All right, so how you would know this in the lab setting would be I would do an experiment. I would put a flame near this, okay, and the flame would get bigger. Or I could blow out the fire and put it in here, and the fire would reignite, or at least glow again. Oxygen is the reignite, okay, or glow again, or make the fire get bigger. Makes sense. We have oxygen around, you know, when we light a match, that's what we need to burn. So if there's oxygen present, then it's going to reignite, okay? Let's take a look at balancing this one. 2 hydrogen, 2 hydrogen, 2 oxygen, 1 plus 2 is 3. This oxygen right here is odd, so we're going to double him. That gives me 4 oxygen. I put it over here to get 4 oxygen. 2 times 2 is 4 hydrogen. 4 hydrogen, decomposition reaction also, because I'm breaking it down. I started with one reactant and produced multiple products. So the two gases so far we focused on is if the end product after the reaction puts out the flame, you're looking at CO2 as one of the products. If it allows the flame to reignite or glow or get bigger, then one of your products is oxygen, and then you would predict from there. Okay, I'm going to stop this video, push this one out, and then I'll continue on a couple more videos and push those out.